Welcome to the webinar on the vision of CAD CAM. My name is Mike Skramstad, and I will be your presenter today. Before we get started, just a little bit about myself. I graduated dental school in 2000 from the University of Minnesota. I am in private practice in Minnesota, and I also spent some time on the CAD CAM department at Spear Education and SericDoctors.com. About half my time these days is spent training dentists to use different CAD CAM procedures, different techniques and strategies, and we do this training both in Scottsdale and in Charlotte. Now, before I get started, again, just a couple disclosures. It's important to go through these disclosures. I am receiving a small financial contribution from Integrated Media Solutions for this podcast. I am a paid faculty member at SericDoctors.com and Spear Education. I do a lot of beta testing, both software and hardware for Dentsply Sirona, and I'm a product consultant for many different companies that we will be talking about today, including Dentsply Sirona, Ivoclar, Noritake, and Vita. So with that out of the way, let's go ahead and begin. Now, when people think of CAD CAM, specifically chairside CAD CAM, this is the type of restoration that sometimes people think. You know, I started using chairside CAD CAM in 2003, and a lot of the different techniques we had back then would result in restorations that look like this. So truth be told, this is one of my restorations that I did. It was on my wife, of all people. And you can see that after about 10 years, it really starts breaking down significantly. Now, this was probably an issue with preparation. It was probably an issue with material. And just overall, the systems in place that we had with chairside CAD CAM were not what they were today. So if you look at some of the other things that we can do, this would be a 15-year recall on a feldspathic ceramic crown that we did. So some of the stuff that we did was very successful long-term, and it can be successful long-term even with the very old materials. Now, this has obviously changed moving forward. We've got many beautiful materials, many different manufacturers that make us chairside materials that can do the job. So the reason I show these slides to beginning is just to open your eyes that chairside CAD CAM can be very beautiful. A chairside CAD CAM can have great longevity, and chairside CAD CAM can have excellent margins. So a lot of this is going to be dependent on the prep. A lot of it's going to be dependent on the material, and just being careful in what you do, and we can have excellent results with chairside CAD CAM. So when looking at evaluating different CAD CAM systems on the market, there's many wonderful chairside techniques, there's wonderful digital scanners, but the main three things that I look at when I'm trying to evaluate a CAD CAM solution is ease of use, software efficiency, and applications. Specifically, how easy is it to use? Can me or my assistant pick it up and actually scan quite easily? Now, scanning is one thing. There's many wonderful scanners on the market today, but what makes the biggest difference when you start talking about chairside CAD CAM is software efficiency. The software has to be extremely easy to use. It has to have artificial intelligence that guides you along the way, minimizing the steps, and be super efficient when you actually use the software. And then applications. What specifically can you do with the system? You know, there's many different applications, from just chairside crowns all the way to digital dentures. So in evaluating what you're going to do, you have to look at these systems and try to decide for yourself exactly what you envision yourself doing in your office. Now, when looking at some of these systems, the main difference, even within the last year, is the accurate full arch scanning. And when I mean accurate, many of these different systems out there can scan a whole entire arch, upper and lower, and it can be extremely accurate. So this has opened up the doors for the applications like we talked about earlier. We can, because we can do these accurate full arch scans, now we can start to think about doing more comprehensive dentistry in our offices. Now, just to kind of show you a nice slide that was taken, was if you wanted to evaluate how accurate these scans are from an occlusal perspective. This is a T-scan, which is going to evaluate not only the locations of the contacts, but also the intensity or the pressure of those contacts. And then you can see the intraoral scan on the right-hand side. That scan is taken with the CEREC Prime scan, and you can see they really correlate quite closely, which is important clinically, because if you're going to take a full arch scan and you're going to articulate the upper and lower scan, you want to make sure that the occlusion is correct. And this actually shows you that it is very, very close to being super ideal in that particular scenario. Now here's a video scanning a full upper arch. Now this video is done with the CEREC Prime scan. And the reason why this video is important is if you go to a trade show or you're just scanning a demo of some of these different systems, you can scan natural teeth usually quite easily. Now, where traditionally we've had issues scanning would be when you have a lot of restorative materials. For instance, it could be PFMs, it could be gold crowns, it could be amalgam composite. Whenever you get a lot of dental materials in the mouth, traditionally this is where intraoral scanners have struggled. Now, in this particular scenario, this is a full arch zirconia case that I'm actually replacing. So what you can see as this video is playing is in 30 seconds, very quickly, the CEREC Prime scan was able to scan this whole entire arch, even with the most difficult of scenarios, which is zirconia. So the scanners have improved quite a bit. It allows us to scan a lot of these different materials and very efficiently and very quickly. Now, there was an excellent study that was done in the Journal of Restorative and Aesthetic Dentistry. This was done by the Medical University of South Carolina. And the reason I like this study so much is because they didn't simply measure trueness just based on natural teeth or a typodont or a model. They created this very unique model that has all these different materials in place. Now, why this is really effective is the fact that it can scan these with all different types of scanner and measure how each of the scanners will do. So if we look at the overall results, and so they used different scanners, all sorts of different scanners, and even different software versions within these scanners, and you can see the results. You know, I would say that most of the newer scanners that you see on the right-hand side do an excellent job measuring the actual trueness. And what I mean by trueness is how close to the standard is the actual scan. So they measure with an industrial scanner, that's going to be your standard, and then they do the different scanners as well on this special model, and they see how close it is to it. So you can see many of the new scanners, whether that's the Trios, the Emerald S, the Trios 4, the Prime Scan, they are very, very good. And even with newer softwares, they tend to improve. One particular example of this would be the Dentsply Sirona OmniCam. Now, the previous version of the OmniCam from like a year ago did not fare so well on this test. Now, the hardware didn't change at all, but the software changed. Now, version 5.1, you can see it's about twice as true as it was just based on a software change. So that being said, we have to know that software is always going to be key. Now, software is key because it allows us to maximize the overall capability of the scanner. The hardware of a scanner is just one aspect of what makes it accurate. So you have accuracy is made up of trueness and precision. And of course, the hardware of this is very, very important, but the software needs algorithms to maximize how to make this accurate. Okay, so that's one feature, and you saw that in the previous slide. The bigger thing with software is if you're going to do chairside CAD CAM, you want the software to be automatic. You want it to be quick. You want to minimize the steps that we have to do as dentists or dental assistants to get the process done extremely quickly. Now, if you look at this video, I'm going to just let this video play for you. And this video is going to be a start to finish case where we're going to do a single unit crown. Now, when I mean start to finish, I want you to watch very closely. I'm going to image the upper jaw. I am going to image the lower jaw and the buccal bite. We'll let the model process, and what you're going to notice is the software is getting so good. This happens to be the CEREC software from Dentsply Sirona, is that it automatically sets the occlusal plane. It automatically recognizes where the margins are at and draws the margins pretty perfectly in this particular scenario. When we get our proposal, the contours, the shape, everything with this proposal is almost right on the money, meaning I didn't have to make any adjustments to this proposal, and I was able to move right to the manufacturing stage. So what I mean by why software is important is, as you watch this video, from the moment I start scanning to the moment I send to the milling unit, we're looking at roughly 1 hour or 1 minute and 40 seconds. Now that is efficient. That is something that any dentist can take and let the software and the artificial intelligence take hold of the process, and it allows us to be extraordinarily efficient and complete the procedure in a timely fashion. Now, we also wanted to show you some of the different applications that are possible with chairside CAD CAM. So when we're looking at, we have partial coverages available. We can do full coverage crowns like we showed you before. We can do bridges. So 3-unit bridges or even longer bridges are possible with these chairside CAD CAM softwares. We can restore implants, whether that's screw retain implants, whether that's a cement retain solution. We can do veneers or cosmetic cases. These are all possible by the software. And we even can take a diagnostic wax up that we got back from our laboratory, overlay that in the CEREC software, and get a perfect duplication of that wax up in the software. So this is just a couple of the things that the software can do because of the new scanner, because of how the full arch scanning is now becoming something that's very, very accurate. Now we're talking about doing digital dentures and partials and super comprehensive type of dentistry that allows us to really open up the doors and the capabilities of these systems. So let's switch gears here a little bit and talk about margin preparation choices. Now, traditionally, when people were getting into CAD CAM, they would be told that you have to do a shoulder preparation. Well, that's not necessarily the case, and it certainly depends on the type of material that you're using. Now, if you're using more of a lithium disilicate or a stronger, higher modulus material like zirconia, for instance, you certainly do not have to prep a shoulder. You can prep more of a chamfer or thinner type margin for these stronger materials. Now, if you just want to look a little bit into the literature, we can look at how the margin is affected based on margin design. So what this study shows us is margin design does not really mean a difference in fracture resistance, even with IPS Emax crowns. So when you're doing lithium disilicate, you can prep a chamfer or you can prep a shoulder, and the fracture resistance really is not affected by much. Now, that being said, if you want to look at a typical glass ceramic preparation for, in this case, Ivoclar Emax, this would be a way that I would prep a tooth. Now, by traditional dental school definitions, this may be termed as an onlay. It's full coverage. I'm calling it a crown. We're covering all the different cusps. Now, the great thing about doing glass ceramic preparations, doing chairside CAD CAM, is we can do much more conservative axial reduction. We're keeping the margins extremely high in the buccal, extremely high in the lingual, and maximizing the amount of enamel that we have to bond to. We also want to make sure in these types of preparation that we have very rounded transitions between where the interproximal box is into the higher buccal lingual. So we can be a little bit inventive. We can prep based on what the tooth needs and not be bogged down by traditional definitions of how we have to prep a crown preparation. Now, earlier we showed you some different slides on margins, an x-ray of a margin. Now, when people say that chairside CAD CAM doesn't have good margins, well, there's actually been research on that as well. Now, this research actually makes perfectly good sense. If we want to look at the true marginal gap made by milling restorations, we can just simply look at the quality of the preparation. So if the quality of the preparation is poor, the marginal gap is going to be higher. If the quality of the preparation, the margins is quite smooth, then the marginal gap is going to be very, very small. Which is good to know that we are in control. It's also, it's a lot of times people tend to blame the process or blame the machine when really it's all in our hands. And so what I've personally found is over the years, I've spent just a little bit more time making my preparation quite smooth because I know that it's going to result in better clinical margins and a smaller marginal gap. Now, based on that, there's different marginal strategies that we can use. This is showing some close-up images of some different burrs. You can see when we look at super coarse chamfers and we blow it up under a microscope, that burr is quite abrasive and quite aggressive. So a lot of times I may start with a super coarse chamfer, but I want to make sure I move into a medium or a fine to smooth that area out. The smoother the margin is, the better your marginal gap is going to be, or the smaller it's going to be. So the question is, can I go from super coarse to fine, or do I have to go from super coarse to medium to fine? We've actually looked at this, and what we realized is if you go from a medium to a fine, it is in fact a little bit smoother. However, if you go to a super coarse to a fine, it's actually quite smooth too. The differences between medium to fine and super coarse to fine are quite negligible, which is good to know because most dentists tend to like to go from super coarse to fine. And we've shown in the study that you might have a little bit more scratches, but the margin's still quite smooth. And this is in fact what I generally do. So based on this information, if you look at these preparations on tooth number 8 and 9, these are preparations that are replacing old ceramic work. You can see that the margins are pretty smooth clinically, which is going to translate. This happens to be the CEREC Prime Scan in the CEREC 5.1 software. You can see it smooth margins clinically transfer to smooth margins in the software, which in the end of the day is going to translate to better margins for your clinical longevity. So let's just go ahead and start going into some of the materials. Now, this is just one slide of a couple different materials. But the reason I put this up here is not to necessarily talk about the manufacturers at all, but more talk about the evolution of clinical outcome. Now, when I started using CAD CAM in 2003, I started with the CEREC system, and the only thing we really had available was a couple weaker materials. We had Vita Mark II, we had a very early version of a Lucite-based M-Press called ProCAD, and we had a composite material made by 3M. So our options were very, very limited, yet our applications, we tried to push them pretty far. So when I say evolution of clinical outcome, maybe we had some results that we pushed too far and were not clinically successful. So, however, these materials have evolved and keep on evolving. And technically what they're doing is making us as chairside CAD CAM dentists more successful. In 2006, we obviously all are aware that Ivoclar came out with lithium disilicate in a pressable and millable form called Emax. Now, the beautiful thing about Emax was it made us more successful immediately because it gave us a high-strength ceramic that we could use pretty much anywhere in the mouth. Okay, so 2006 was a huge moment in chairside CAD CAM. It made us all very successful. Now we move forward to 2016, so 10 years later, we're in the middle of the boom of zirconia, and now zirconia has moved into these chairside systems, which allows us to actually mill and sinter zirconia chairside. Now this is what's called CEREC zirconia, made by Dentsply Sirona, and this is a super high-strength zirconia that we can mill in roughly 10 to 12 minutes and sinter in under 15 minutes, which has brought the chairside zirconia process even chairside. Now zirconia, this is a high-strength, rather opaque zirconia, but it gives us a material for second molars on patients that, for instance, may not want to use gold. Now these are just 3 examples of materials that we have used over the years. If we really want to get into all the different materials that are available for chairside CAD CAM, These are just some of them that I've taken photographs of in my office. So we've got many different manufacturers producing many different materials. There's a bunch of different zirconias, from the high-strength zirconias to the aesthetic zirconias to different feldspathics to different lithium disilicates to lucite base. So you name it, we probably have the material, which is great because there's different materials for different clinical indications, and we can choose based on those indications what material is going to give us not only the best longevity, but also the best aesthetic result. So if you want to look at just a typical case that I would treat on a weekly basis in my office, on the left-hand side, you see the pre-op situation. Now, unfortunately, that was a CAD CAM restoration done with feldspathic porcelain that I treated in roughly 2004. So fast forward about 10 years, you can see that feldspathic restoration had fractured. Now, this again fits into our vision of how the materials have actually transformed our clinical outcome, that the feldspathic porcelain on a second molar on someone who is fairly aggressive with their bite is probably not our best clinical choice. So nowadays I either use zirconia or lithium disilicate generally in these scenarios. So we went ahead and we prepped the tooth that you can see on the right-hand side. Now, based on that preparation, you may say that that looks fairly aggressive. Now, but you're not also seeing the whole clinical scenario. And when I transfer that to the buccal view, you can see it's more of an onlay type of situation. So again, if you go back and you look at that picture, it can be a little bit deceiving if you're just looking at the picture from the occlusal view. So if we go to the buccal view, you can see that it's more of an onlay. Now, it could have brought that buccal margin down a little bit, but this has been clinically successful for many years now. And so these onlays have worked very well with maximizing enamel. So what we'll do is we went ahead and we imaged this with our chairside system. At this particular time, it was a CEREC OmniCam, and we drew the margins, and we have our nice proposal of our restoration there on the right-hand side. We milled this out of lithium disilicate or Emax, and you can see our final immediate result here on the right-hand side. So this is an Ivoclar Emax HT crown with a little bit of staining and glazing. So I think we've got a fairly acceptable result here. And this has served the patient well for many years now. And it's made me feel quite good that we have these materials that are a little bit stronger, a higher modulus, higher fracture toughness material that we can use in different clinical scenarios in the mouth. And they actually are making us very successful from a longevity standpoint. So in the next slide, we're looking at how artificial intelligence can also affect how the computer thinks. So what I mean by this is if you look at these pictures here, the pictures are a little bit smaller, but on that left clinical picture, you can see a very typical clinical scenario that we run into all the time. It's just a larger or medium-sized amalgam restoration that has a small fracture. Now, in traditional dentistry, we may think about preparing this tooth for a full coverage crown, maybe doing a buildup. With CAD CAM, we can think a little bit differently. And what we did here is we can see that we removed it and we actually left some of the cusp or that whole distal marginal ridge and part of the buccal and lingual in this restoration design. Now, a lot of this, where I keep these cavo surface margins is going to be dependent on occlusion, of course. We don't want the opposing to be grinding on that cavo surface interface, but here there is no occlusion or very light occlusion touching, so we thought we could be successful. And the main thing is when you're looking at these types of designs, you may not ever think, unless you have chairside CAD CAM, to be this conservative. And I don't know if you want to call this a 7/8 crown, but it works. And what the software will do using its artificial intelligence, it will analyze the remaining tooth structure on that particular tooth. It will analyze the adjacent tooth, and it will come up with a proposal for our restoration that's very close to what is fitting in nature. It's not a database tooth being put into the space. Every restoration is going to be different based on what the patient has as far as anatomies and contours in their mouth. Okay, so again, there is our restoration. You can see that when I see something like this and somebody asks me how I'm going to prep it, the answer is generally, I don't know. I need to remove the restoration, remove any decay or caries that's present, and then we'll go from there. And oftentimes it'll surprise you how conservative that you can be. So if we look at this restoration, this is a 10-year recall of this lithium disilicate onlay or 7/8 crowns. So you can see that these can be very successful, and they have been very successful. So don't be closed-minded in how you go ahead and design these preparations, because you can be a little bit more conservative, and oftentimes it's going to surprise you from a clinical perspective how successful these types of restorations can be. Okay, so now let's transition from a lithium disilicate into more of a zirconia type scenario. So here you see the dry milling on these videos of zirconia. And this was introduced in 2016 by Dentsply Sirona. Now, obviously, zirconia has to be milled. It cannot be pressed or it cannot be printed. And so everybody that produces zirconia all across the world, they're doing this with a milling unit. Now, most of the labs are using more industrial 5-axis mills where they're milling multiple zirconia restorations out of a puck. This will, if we're going to bring this into the dental office and have a dentist do this chairside, we need carbide dry milling of this zirconia. Now, it's possible to do with diamonds, but it's the most efficient way to do this is with the carbide burrs in a dry fashion. So Dentsply Sirona introduced the dry mill, chairside mill in 2016, which has allowed us to do zirconia restorations. So what are the advantages of zirconia, and why would I personally consider doing this? Is first off, it allows more flexible and conservative preparations. Now, I showed you a glass ceramic preparation a few slides earlier, and that is usually how I prepare for glass ceramics. I'm a little bit more inventive. I rely a little bit more on adhesive type of dentistry and bonding these restorations in. Now, when I do zirconia, I tend to think a little bit different. Now, zirconia, I can have more flexible preparations. So let's say I'm replacing a PFM or a gold crown that's already prepared by another dentist. It might be subgingival. I can stick with that preparation and just clean it up and be able to mill zirconia in office to adapt to some more traditional type of preparations. Another thing is I might be able to reduce the tooth much less. Because zirconia is much more high strength, I can get it down to even 0.7 millimeters oftentimes if the occlusion is very, very tight. So we have to reduce less tooth structure. We can be a little bit more conservative. All very good reasons to consider zirconia. Another reason is its very high flexural strength. Now, we have to be a little bit careful talking about flexural strength of zirconia because not all zirconia is created equal. What we're talking about now is the super high strength zirconia. This would be like a Bruxier from Glidewell, or a Ceric zirconia, an Ivoclar Zircad, a Vita type of high strength zirconia. So there's many high strength zirconias on the market. The advantage is many times they're very, very strong. The disadvantage is oftentimes they're very opaque, but they do serve their purpose in high stress areas like second molars. The other thing I noticed when I started doing zirconia is the fact that the margins were extraordinarily precise. The fit was like nothing I've ever seen before. And I guess that makes sense if you think about how zirconia is actually milled. So if I go back to the milling of this zirconia, and you can see in this video, what zirconia does is it mills about 23% larger than the final clinical result. So because it's milling larger, and then it's going to be shrunk down by a certain percentage in that sintering furnace, these carbide instruments can get into smaller little nooks and crannies in different areas, which is going to make it a little bit easier to get more precision and more detail in the milling. So I really like that ability of zirconia to be very precise, have good anatomy, and excellent marginal fit. Now, some other advantages, important advantages, is traditionally zirconia is less expensive. It's less expensive to manufacture. The blocks are less expensive. I'm sure many dentists have realized that if you send this off to the lab, it's less expensive even there. And probably the number one reason why I love zirconia after all these years of doing glass ceramics and chairside CAD CAM is you can conventionally cement it extremely predictably with something like resin modified glass ionomer. So if for those dentists who find bonding very difficult or don't really want to do it, zirconia gives you a nice solution that you can actually cement it. Now, if you want to look at a clinical case here, this is a case that I did on that second molar. I realized that the first molar also very likely needs a crown, but this patient is in the 1 crown a year club. I think by now we've actually replaced that restoration and just not updated the picture. So this is a chairside high-strength zirconia that was polished only on the second molar. Now this looks as if it's stained and glazed, but there was a little infiltration added. Now that's a topic for a separate day, but what infiltration means is I just added a little bit of color in that pre-sintered state, and it's kind of like dyeing an Easter egg. When you sinter, when you add that color to the pre-sintered or white zirconia and you put it in the sintering furnace, it will bake right in, just like dyeing an Easter egg, and then I can hand polish the restoration and you can get this result. So I think this result is quite good, specifically for a second molar. It's a little bit opalescent, a little bit opaque. That's just the nature of high-strength zirconia. But what it does is this appointment was done start to finish in 1 hour and 25 minutes. Now, at the very end of the presentation, we'll talk a little bit about time. And my goal with every chairside restoration is 1.5 hours. If I can kind of keep it below that, I'm quite pleased. When zirconia was first released, I said we better be efficient enough to do it in 1.5 hours. Otherwise, it doesn't make sense for us as chairside dentists. And you can see with these different workflows, the dry milling, the fast milling, the fast sintering, we can actually do these restorations quite efficiently in our office. Now, looking at some different zirconias that have been brought to the market, this one is Katana STML. STML stands for Super Translucent Multi-Layer Zirconia. And why I'm showing you this slide, this happens to be a picture of the Ceric Speedfire furnace, the chairside sintering furnace made by Dentsply Sirona, is traditionally if we want to get into a scenario where we want to sinter a more translucent zirconia. So the zirconias I showed you before, a little bit more opaque, we want them to make them look a little bit better. And so Katana came out with a very novel and very great sintering cycle that allows you to sinter their material in 18 minutes and 39 seconds. Now, traditionally, a translucent zirconia would take 9 hours to sinter. And the fact that they were able to fabricate their powders specifically with the purpose to fast sinter has made chairside translucent zirconia a reality. So if you go ahead and you look at this zirconia restoration on tooth number 14, you can see this is the day I inserted it, so there's a little bit of tissue inflammation. But if you look at that translucent, this translucent Katana STML zirconia is looking a little bit closer to glass ceramics. So it's giving us a higher strength, somewhere in the neighborhood of 750 megapascals of flexural strength, zirconia that actually looks pretty good. We can sinter pretty fast, and it's a chairside procedure. So we're going to start to see more and more of this, different manufacturers making translucent ceramics that can be manufactured much quicker. So this happens to be the Noritake Katana STML restoration. They also have a bridge. So this bridge is a little bit higher value than I would have liked it. But again, this is a zirconia bridge fabricated in my office with an 18-minute and 39-second sintering cycle. So again, it's a little bit high value. I could have chose a darker shade, but if we look at the overall translucence, if we can actually get around the fact that the value might be a little high, the shade might be a little bit bright, the translucence is looking a little bit more towards glass ceramic and a little less like traditional opaque zirconia. So let's go ahead and transition to another topic, which is copying something. Now, this is an interesting case and one that sometimes we run into. Now, this patient has a tooth number 7 that's endodontically treated. There's a fracture down the lingual and decay interproximally. So we need to do a single restoration on this lateral incisor. Now, some may say easy enough. I can just prep that, send it off to the lab, get a crown, no problem. Now, the tricky part is in my experience over the last 20 years of practicing dentistry, it's very easy to make a tooth look pretty. So if this patient was going to do, all the front teeth, a cosmetic makeover, no problem, we can improve his smile. What's much more difficult is making an ugly tooth. Okay, so if you look at this and you want this tooth to match his overall smile, I want you to visualize in your head what a PFM would look like on that tooth, right? It's going to stick out. We've all seen this. So what we need to do is we want to create a restoration that mimics the incisal wear. We want to probably have a space, and we want to really nail the overall shape to match exactly what that patient had pre-op. Now, this is done with the CEREC system. Other systems and other manufacturers have something similar that you can do, but we're going to call this biocopy. And what copying means is I'm going to scan this initial pre-op situation before I prep the tooth, and it'll allow me to actually copy that exact shape in my final restoration. So if we go ahead and we look at the preparation, this is, you can see I have a little bonding. I did a small little buildup here. So on the tissue, you see a little residual bonding, but that is my full coverage crown prep. So I imaged the pre-op first, and then I prepared the tooth for a full coverage crown, and now we're going to image the actual crown. So there is the crown marginated in the CEREC software, and we're ready for our initial proposal. Now, the cool thing is when I got my initial proposal, it was an exact match of my pre-op situation. So on the right-hand side, you see the facial surface. It copied the little space between the lateral and the central incisor. It copied the incisal wear. If you look at the lingual surface, it even copied the lingual anatomy. Now, lingual anatomy on anterior restorations is still quite important. It's there for a reason. This is controlling the patient's function. So the fact that we can copy that exactly is a huge benefit. Now, the material that we chose to use on this particular restoration was a material called Vita Trilux. Now, Vita is a manufacturer that produces many different materials. This one happens to be a multi-layer feldspathic material. The reason I chose this material is because the patient has a very warm value in their teeth, and I feel like feldspathic does a very good job. Yes, feldspathic is a little bit weaker, but a lot of times in these scenarios, I'm very concerned about matching teeth. So even though this is not a cosmetic makeover, I still want to make it actually look quite good for the patient. The other reason we use this is because it's multi-layer. This patient has quite a bit of incisal translucency, and you can see these 3 different zones of translucency, which is going to allow us to get a nice result. So there you can see the final result of this final crown. So we tried to make an ugly looking tooth, and I think that we were actually quite successful. You can see how that feldspathic porcelain blends in fairly well with these adjacent teeth. Now that showed us copying an existing restoration. Now, the other cool thing that we can actually think about doing is we can copy an existing restoration, we can copy an existing tooth. This is very effective if we need to copy a survey crown for a partial denture. Now, what if we're doing a more comprehensive type of case and we want to copy a diagnostic wax-up? Now, I'm just showing you some different options for diagnostic wax-ups. We have a conventional wax up. You could get a 3D printed wax up either from your lab, or maybe you're 3D printing a wax up yourself. Maybe they're milling digital wax ups, or maybe you have a software that can actually do a diagnostic wax up completely digitally. All the concepts here doesn't matter how you do the wax ups, the concept is the same. We're going to scan the wax up and then copy that wax up exactly onto our final result. Okay, so if you look at this particular case, this was a full mouth reconstruction that we did. Every single tooth in the whole entire mouth is going to be restored. And so you can see this patient on the upper left-hand side. This patient had old restorations that were failing, but more importantly, they did orthognathic surgery to reposition the jaw. So you would see, if you were looking at the occlusion of the pre-op, that only her front teeth were touching. Okay, so what I did as a dentist here is I went ahead and I scanned the upper and the lower and the buccal bite in the CEREC Prime scan. That is that upper right-hand picture. So you can see that I was able to replicate her pre-op situation digitally by scanning the upper and the lower, and then I sent this information to my laboratory. Okay, now some of you will choose to do these diagnostic wax ups yourself. I choose to send this to my digital laboratory. We can send this in any file format that the lab needs. It doesn't have to be a CEREC lab, for instance. It can be sent as an STL file, a PLY file, an OBJ file, basically any file type that your laboratory requires, because different laboratories use different software. Some may use a Dentsply Sirona in-lab software. Some may use ExoCAD, some may use 3Shape, some may use DentalWings. There's many different softwares used by laboratories, so whatever they need, we can get them that file. So on the lower, you're seeing this digital wax up. This digital wax up happened to be done in ExoCAD, so we waxed up the whole entire mouth, not only for cosmetics, but also to redo the occlusion, which you can see on the lower right side. Okay, so once we have everything worked up, we can take this information. Now, I'm not going to go through this whole entire case. There's a lot to actually the workflow of completing a full mouth reconstruction. But the gist of the situation is we're going to replicate that digital wax up into the final EMAX restorations. So what we happen to do is we 3D printed the model of the diagnostic wax ups, or more specifically, I had my laboratory 3D print it and mail it to me. I have a 3D printer, but oftentimes I will utilize the laboratory if they're already doing this particular work. We can use this diagnostic wax up for many different things. We can scan it in the copy folder to have our final restorations be exactly the same as the wax up. We can use it for preparation guides. We can use it for provisionals. So there's many reasons to have a physical model of our diagnostic wax up. And here you can see the final result. Now, truth be told, this is very white, this is very opaque. We've all had these patients. This is what they required. They were from California. They really wanted white teeth, and so we have to deliver what the patient wants. So looking past the blinding white nature of the final restorations, what we can see is the final restorations really copied that wax up very closely, and most importantly, it actually restored her function, restored her occlusion. So if we look at a better picture of her before and after smile, what we can see here is the patient really has a nicer smile. The teeth are occluding right where they're supposed to, and we have a very happy patient. So when looking at these couple different techniques, we can actually scan anything and copy it, whether that's a diagnostic wax up like this final case, a more comprehensive case, or even that lateral incisor, which was a much simpler case, but copy still is very, very effective in some of these chairside procedures. Now, the next topic I want to go into is the chairside fabrication of abutments. Now, here you're seeing the concept of a hybrid abutment. Now, what I mean by hybrid abutment is we have an EMAX restoration, or it could be zirconia. This is just showing you an example of the materials that we can use over a titanium base. But the concept of a hybrid abutment is the fact that we're taking a restoration, whether it's lithium disilicate or zirconia, and we're bonding it to a titanium base. Now, this concept of a hybrid is actually taking advantage of the strength of the titanium into the implant itself, and the beauty and aesthetics of either the zirconia or Emax over the top. Okay, so we have the ability to do this either cement retained or screw retained, whatever the preference of the dentist is, or whatever the clinical scenario calls for. Now, the great thing is if you are placing your own implants and you're designing these, we often can actually get a very good idea of how we're going to do this just based on the planning. So if you look at the planning of me merging a CAD CAM file of a desired crown. So what I did is I imaged the edentulous space. The little blue outline in that middle radiograph shows you where I would like the final restoration to be, and then we plan the implant underneath. Based on that particular plan, you can see that this is very likely going to be a good case for a screw retained. And then when I executed the restoration, 4 or 5 months later, you can see that it turned out to have the screw access hole in the exact same place. Now, it's also possible to do a cement retained solution. So in this particular scenario, we chose to do a two-piece that is a zirconia hybrid, meaning a zirconia custom abutment bonded to a titanium base and torqued in the mouth with an Emax or lithium disilicate crown over the top. So both situations work quite well, and I'll often decide just based on the clinical scenario or the patient's needs on which one that I do. But the important point is you can execute both. Now, one of the very coolest things that we can do is the fact that we have the ability to do provisional restorations. Now, traditionally, doing a provisional restoration in the more analog types of approaches is one of the most difficult situations that you can actually do. So, making this, having this patient come in and needing an immediate provisional on tooth number 9 is not an easy task. Well, chairside CAD CAM has made this monumentally easier. So here you can see this is an immediate implant placed on tooth number 9. So we extracted the tooth, put the implant in there, and the same day of surgery, we can go ahead and put in a scan post and scan body. So the little triangle on top of that cap will allow us to record the position of the implant in the software. And then we've got all these nice PMMA or provisional type materials that we can mill chairside. So we can design this contour outside the mouth indirectly to ideal, and then we can go ahead and insert this restoration to get the tissue to heal. Now, this is obviously a healed shot multiple months later. This happens to be an Ivoclar TelioCAD restoration. It's a little bit shorter to minimize the forces put on it, but you can see what the advantage of using CAD CAM for our immediate provisionalization of implants. Now, moving on to implants, this hybrid solution is not going to be right for every clinical scenario. So it's important for us to have options. We may not want to restore it ourselves. We may not want to use a titanium base on every scenario. So the great thing is we have the ability to scan any scan body from any manufacturer that we want with these chairside systems. So again, this happens to be scanned with, I believe at this time it was the Dentsply Sirona OmniCam, the CEREC OmniCam. That scan body is different than the one that you saw a couple slides ago. This is a scan body from Straumann. Now, we wanted to use a Straumann because I felt that this was not the greatest case for a titanium base. And so I scanned the Straumann scan body and send it to my laboratory to have them make a more customized abutment for that lateral site. And you can see in the picture above, that's the final restoration on tooth number 10 using a laboratory to fabricate the abutment. And then I fabricated the final restoration chairside in my office. Now, there's multiple different workflows. The beautiful thing is anything that we can imagine from implant dentistry, we can now do with these chairside systems, whether that's sending it to your laboratory, whether that's sending it to a place like Atlantis or Straumann. Anything that those companies can produce, we now have the ability to execute with our intraoral digital scanners. So we can make full titanium abutments, full titanium abutments, gold-plated abutments, zirconia restorations, UCLA, multi-level, multi-unit abutments. Anything that we can do from an implant workflow perspective, we can do digitally, which is super exciting. Even if you want to look at some denture workflows. So as these videos are running, you can see this is me scanning with the CEREC Prime Scan. On the upper left-hand side, we scan a fully edentulous arch. On the upper right, we scan that patient's denture. So we have the ability to actually scan the denture in one of our catalogs with our intraoral scanner, send the files of the edentulous scan and the scan of the old denture, and the lab can merge together all these files in their laboratory-based softwares, and we can go ahead and duplicate this. So on the bottom pictures, you're seeing a new denture being made. You can split it into multiple different parts. You can do many, many different things with these new digital scanners. So like I said at the very, very beginning, all these new scanners are so accurate that we're getting into more comprehensive things that we never thought about doing, and digital dentures is just one of those things. Now, how about advanced implant applications? Well, yeah, this is a super important topic. I see people talking about this quite often. And what you're seeing here is you're seeing a bunch of different scan bodies scan to make more of a hybrid type of solution. So this is obviously more of a laboratory-based communication. I'll scan these based on the workflow that my laboratory tells me, and then we're going to go ahead and send this to the lab, and they can design the restorations. Now, the big question that many people ask me is this accurate? Okay, can you scan for hybrids, and is it accurate? Now, the best thing that I can say is I know that this is a little bit of a shocking picture, but I like this study, again, done by the Medical University of South Carolina, is because this is a cadaver upper arch. It's an edentulous cadaver upper arch that they place a bunch of implants, put in these scan bodies, and they go ahead and scan with all different scanners, just like the original study that I showed you, and they start to evaluate, is it accurate? And they even had students and faculty do it. And what we're seeing is the deviation in the full arch, even with these bigger cases, these full arch hybrid type cases, is really working out nicely, and it's starting to be very accurate. So this is, again, a possibility. It's very early on in the process, but there's many wonderful dentists that are pushing the envelope on this. They're doing cases, they're seeing the results, and they're seeing that it actually is working quite well. What I want to show you now is just the ability of a lot of these different patient monitoring applications. So what I mean by patient monitoring applications is these are a picture of, or this is a picture of an upper and a lower arch. This is a post-orthodontic picture, actually. You can see some maxillary collapse. You can see a lot of recession. And when you see these patients, a lot of times we're trying to educate the patients, telling them that they might need some dental work, maybe some soft tissue grafting, maybe orthodontics again, or maybe some comprehensive veneer type solutions for aesthetics. Sometimes the patients want this. Other times the patients do not want this, and then they ask you that very important question. Is it getting worse? Do I have to do it? And oftentimes we don't have the documentation to quantify that question. And so what a lot of companies are starting to do is creating softwares on how to actually quantify that particular scenario. So if I look at these two scans, now, these two scans were taken at a 4 years apart. In 2015, I scanned this patient right here. So in 2015, we scanned this patient, and then in 2019, we rescanned the patient. So as these videos are playing, you can see how they're rotating around, and they look relatively the same. If you look very closely, you might see some difference in how they look, but relatively pretty close. Now, one of the softwares that's brand new just released in 2019 in October is a software called AuraCheck 5. Now, Dentsply Sirona released this software, but anybody can buy it. It's completely open flat platform. It runs by putting STLs into this software. So even if you have different scanners, you can use this software, or you can mix different STLs from different scanners. Maybe you have a trio scan from one dentist that, or excuse me, maybe they saw one dentist for many years and that dentist had a trio scanner. Now, let's say they come to your office and you have a CEREC Prime Scan scanner. And you're like, it would be really nice to know what the preoperative situation was 4 years ago. Now, obviously, this is very early on, but where I envision this process to go is when a patient transfers offices, no longer are we just sending x-rays and different patient documentation from the chart. We should be sending STL files if we have that. Because now what I could do is I could take the STL from 4 years ago from a different dentist, I could bring it into the AuraCheck software, and I could create a timeline. I could superimpose these STL files and see what exactly is actually happening with this patient over a period of time. We can monitor gingival changes. We can we can monitor tooth wear, abrasions, erosions, fractures, all these different things we can monitor. So if we go back to this particular patient, now we can look at this recession. So we have the baseline that we scanned. Now I imported that in 2018, but we have the baseline of 4 years ago, and now we have the new scan from 2019. So what if I play this video, you can actually see that I'm taking one of the jaws and making it a little bit transparent. And now the patient will say, you can show this interactively to the patient and say, your recession is actually getting worse. Maybe we should consider doing something. And if they asked you, well, how much worse is it getting? There's actually even a way to quantify that. So if we go to the next video, we can actually go over to the right-hand corner and turn on the distances. Now you can see all the changes in the different colors. So yes, we do have some fairly significant changes. We can turn on this cursor detail and we can see, so how much more recession? Well, roughly 0.3 millimeters. How much deeper has that abfraction lesion got? Not much, maybe 0.05 to 0.08 millimeters, but we have a way to actually quantify these changes in the mouth. Okay, now from more comprehensive quantitative changes, we can actually look at this and say how much tilt. This video is going to actually show us, well, the facial of 8 and 9 is actually lingualized. So we've got a little bit more of a retrognathic situation. We can look at all these different problems and we can see that this is causing, some tilting of the actual teeth. So no matter what you want to analyze, you can overlay STLs, you can create a timeline. It's very early on in this process, but again, I see this moving forward as a standard in how we're going to monitor our patients, how we're going to communicate with other dentists, how we're going to communicate with specialists. So it's a very, very important step along the way in our workflow to better, more comprehensive communication with our digital scans. Now, I want to end really quickly with just appointments. One of the questions is, can I integrate it with my office? We hear that I have a very, very busy office. This is just an example. They're really of what a schedule may be. And just say, I stagger my office. I have 2 rooms running at the same time. How can I really make this work? It's an extremely important, if not the most important question, because many people I see say that I can buy into the digital scanning. I see the benefit of that. I really want a chairside mill, but I'm having an issue kind of conceptualizing or visualizing how this is going to work into my busy schedule. Well, here's kind of how we look at the anatomy of the CAD CAM appointment. How do we make this work? Well, you really need to separate it into, different sections. What does the doctor need to be doing? What does the dentist need to be doing? So when I think about that, I think oftentimes about where does the dentist need to be in that particular appointment? And I also want to run on that 90-minute appointment. Okay, so obviously the dentist in most states is going to need to be there for the anesthesia. In all states, they have to be there for the prep. Sometimes, some states allow hygienists to anesthetize, so that might not be exactly the same. But me as a dentist, I will go in, I'll usually anesthetize the patient, I'll prep the tooth, I'll image it, and I'll design it. Now, in other offices, the dentist may not do the imaging, the dentist may not do the designing. I see many offices where the staff members have learned to do this. So if you separate it into 30-minute chunks, the first 30 minutes, the dentist likely needs to be in the room. The second 30 minutes, this is the manufacturing process. This is where my staff takes over, where the dental assistant chooses the block. She chooses the shade. She puts it in the milling machine, mills out the restoration, tries it in, stains and glazes it, gets it ready for bonding. And then I come in that last 15 minutes or so, and I bond the restoration in. Okay, so when you start to look now, this appointment looks a little bit different. Me as a dentist, I can still work with the same schedule as I was working with before. I can go in for the first 30 minutes and start with that appointment number 1. Then my dental assistant will take over the process and do all the indirect stuff, and I can be in appointment number 2. And I can go back and forth, and you can be just as efficient. And in fact, you're going to be more efficient because you're completing these restorations in a single visit. So you may have, it just depends. Maybe you're doing another crown in the other room. Maybe you're doing a filling. Maybe you're doing an exam. So this is just one way that even in the very busiest of office, you can make this technology actually work quite well. In other offices, you may just use that time in the middle to just relax, catch up on paperwork, drink a cup of coffee. Every office is different, but the point is you can actually make this work in any office that you want, so you can book appointments the same in your CAD CAM office as you do with traditional dentistry. So to finish off this presentation, mainly I hope that I was able to convey the ease of use, the software efficiency, and the applications. All these are extremely key. They're all very important in how I evaluate the actual what I'm going to use. And it's also important to evaluate the vision of the company. It's critical to kind of consider all this when you're considering how to integrate CAD CAM effectively into your office and be successful. There's many ways to start, but ease of use, efficiency, and applications are always going to be key to what you're going to do in your office. Now, I put a couple links if some people want to look at some different things that we talked about. The Cyfex is going to be the link for that patient monitoring system. There's some different things on Dentsply Sirona and some independent research and studies looking at all these different scanners. And if you want to read more about that, you can read them there. As far as questions, we did have a couple questions come in, and we'll cover those really quickly. If you have more questions, you can certainly contact Integrated Media Solutions or myself. But one of the questions is if I'm interested in, let me see, I'm interested in looking into one of these systems, how do I get more information? Well, the easiest way to get more information is just to contact the specific company that you're actually working with. I can give you, obviously, I mainly work with Dentsply Sirona. So if I was working with Dentsply Sirona and I wanted to get more information, you can go one of two routes. You can either contact Dentsply Sirona directly. Dentsply Sirona has manufacturing representatives that specifically are there to cater to the needs of the dentist. You can also contact your distributor. Both Patterson Dental and Sullivan Shine both have representatives that are focused specifically on CAD CAM that will be able to answer any questions and refer you into the right direction. Now, also in that direction, if you're looking at any other system, because there's many systems out there, both Patterson Dental and Sullivan Shine are distributors of most of these systems that we talked about when I showed you the different slides of all the different systems. If you're interested in learning more or comparing or contrasting or looking at the ease of use, efficiency, and applications and how different systems compare to each other, the first place that I would go to is going to be either Patterson Dental or Sullivan Shine, because they've got representatives that are effective at looking at all these at all the systems and helping you decide which system is going to be best for you. Okay, so the next question is, you showed a lot of materials. I am familiar with lithium disilicate or EMAX, and I'm familiar with zirconia. All these other materials are kind of foreign to me. How do I learn more about these materials? Well, you know, you're right. It's a good thing and a bad thing in some senses, is because with more materials, it's better for us as a dentist because we're going to have more options, but also it's going to be more materials to learn. And so what I would recommend for most dentists who are starting out, if you choose to mill CAD CAM in office, I would start with what you know. So, which means for most of you, I would start with a lithium disilicate or one of those high strength glass ceramics, whether that's Celtra Duo from Dentsply Sirona, or whether that's EMAX from Ivoclar Vivadent, or zirconia, whether that's the Ceric zirconia, an Ivoclar Zircad, a Katana. Start with what you know and move on from there. Now, as you get a little bit more experience, when you start moving into some of the more cosmetic types of cases, and you want to learn more about an M-Press or a Vita or Feldspathic or you know, all these different materials that we showed in those slides, then you can start experimenting with one of those. So I hope that helps. Okay, the next question is training. Okay, so if you buy one of these systems, I can certainly understand that nobody wants to be left behind, and so this is actually probably the most important thing. And again, I only can speak to what I know. I don't know every training protocol for every system on the market, so let me just speak again to what I know, which would be Dentsply Sirona's actually protocol. So again, if you want more information on how the training is going to run or what you get, definitely talk to your representative, which either from Patterson Dental, Sullivan Shine, or the manufacturer rep themselves should be able to guide you. But if you bought, let's say, a Ceric machine, whether that's just a digital scanner alone or it's the full CAD CAM system, I can kind of speak to that a little bit. So what's going to end up happening is you're going to, because training is critical and it needs to be the most important part, because you want, it's very important to everybody that you're successful with this machine, and they're there to hold your hand and guide you in the right direction. So what you're going to get with that is you're going to get the delivery of the unit. You get a basic training, which is going to be 2 days to get you kind of started. We also, you also will get a membership to the website cericdoctors.com. That's a great website because it has thousands of videos where you can sit at your house and learn exactly whatever you want to learn in the comfort of your house. Now, speaking of those courses, whenever you buy a Ceric machine, you also get, along with the cericdoctors.com, along with the basic training, which is done by your either Patterson Dental or Sullivan Shine, you also get another course included, which is level 2. Now, level 2 is kind of mastery or introductory mastery of the Ceric system, and that is located either in Scottsdale, Arizona, or Charlotte. So again, I can only speak to what I know and have personal experience with. But what I will say is I know it's extremely important to all the different companies to make sure you're successful. So make sure that you talk very closely with whoever the representative is for that particular system, and they will guide you down the right path. So that looks like that's all the questions that we have at this time. If you can think of any other questions, please feel free to email me at mike@cericdoctors.com. I will be happy to guide you the best I can in the right direction. I hope this webinar was enlightening and helped you kind of understand some of the different things that we can do, some of the advances that we've made over the last several years. For me specifically, the last almost 18 years of using chairside CAD CAM, the changes have been monumental, and they're actually coming quite fast. So who knows where we're going to be a year from now. But it's all very exciting, and I look forward to all you guys kind of joining in and learning CAD CAM. Thank you very much. We'll talk to you guys soon.